Hess's Law.
Let's turn off the light.
Hess's Law. The change in enthalpy of an entire reaction is equal to the sum of the changes in enthalpy in each step of the reaction. I know that kind of doesn't make a whole lot of sense, so you're going to have to see what I'm talking about here in a second. It's kind of like this. You go on a road trip, okay, and you're going to drive from Lebanon to New York City. And we'll say, to make it easy, it's 3,000 miles. You're probably not going to get in your car and drive 3,000 miles without stopping. Probably not going to happen. So you're going to get to, maybe you're going to go down and across. So you'll get down to San Francisco or Sacramento. So you go to Sacramento first, you stay on the I-5 and stay for the night. And then you're going to drive from there to Las Vegas and stay for the night. And then you're going to drive from there, right? And so all these parts. So when you add up all those little mini distances you drove, it will equal the entire 3,000 mile difference. Does that make sense? All the individual parts add up to be the same as the whole. You also have to see what I mean. For example, carbon mixing with oxygen and making carbon dioxide has an enthalpy of negative 393.5 kilojoules. But it doesn't actually happen that way. How it actually happens is that first it makes carbon monoxide, and then the carbon monoxide combines with more oxygen to make carbon dioxide. So those two steps put together equal the same as that one step by itself. Make sense? Because then what you do here is you add them together, and if there's anything on both sides, they cancel out. So for instance, here, carbon monoxides both cancel out. So you're left with a carbon plus 2 halves, which is a whole oxygen, gives you carbon dioxide.
But why wouldn't you cancel out the O2?
Because they're on the same side.
Oh.
So they add together. Do you remember spectator ions? You remember net ionic equations? It's kind of the same thing. There's carbon monoxide sitting on this side, carbon monoxide sitting on that side, so you can get rid of them. So, same exact equation, same exact answer.
Are we going to have to be able to break it down like that?
Yes. So here, for instance, is a, here's what a test question looks like. I want to know the change in enthalpy of this. But what I give you are these two equations. So what you have to do is you have to arrange them so the stuff you don't want is going to cancel out and the stuff you need gets to the correct number of them and blah, blah, blah. Again, I can't really just explain this. I need to show this. So here's the steps I always do to follow. The first steps I do, number one, is always get rid of the unwanted. So that means I look here for what I want, and then I look here for what I have, and I try to figure out what I have that I don't want. Does that make sense? So for instance, there's no carbon in this at all. None. So what I need to do is get rid of anything with carbon. So that means I need things to cancel out. That means they need to be on opposite sides of each other. So for instance, carbon monoxides need to cancel out. Well, right now they're on the same side. So they're not going to cancel each other out. So what you do is you can flip an equation. We'll get there in a second. What you need to keep in mind is put what you want where you wanted. Now, I put this number 2 because you can kind of fix that at the end, and you'll probably see some examples where that happens. But you can probably fix that at the end if you need to. So, for instance, my Fe2O3 is on the left. I want it on the right. Okay? So I'm seeing a couple things here. I'm seeing that see how these are on the same side, and these are on the same side? They need to be on opposite sides so they cancel each other out. And this is on the left, and it needs to be on the right. So I could fix this whole thing if I just flop this equation. So instead I would have 2Fe plus 3CO2 gives me Fe2O3 plus 3CO. So what I did is I just reversed the equation. You guys see exactly how I did that? Stuff on the left, one on the right, stuff on the right, one on the left. Now, the trick is, if you do that, you have to reverse the sign of this. So it was negative, now it's positive. Alright, so what we want is where it is. We are getting it set up so we can get rid of what we don't want, but what's the last problem here? Is my carbon monoxide going to be canceled out? What's the problem with these two? One of them would. So what I would have is this would cancel out, but then I'd be left with 2 here. You can multiply the bottom one by 3. So you'll have 3CO plus 1.5O2, which is good because that's what we needed anyways, gives you 3CO2. And then just like last time, if you multiply this by 3, you have to multiply this by 3, which I don't know off the top of my head. What the heck? So negative 848.88 kilojoules. Okay? So that means you're not, this one's gone now. Okay, so now, and this is one of those where you use a lot of paper. Just trust me. Use a lot of paper. If it helps you to completely rewrite this, I mean, I've seen Hess's Law problems take an entire sheet of notebook paper. It sucks, trees, yay, whatever, but this looks kind of messy. Sometimes it helps people kind of process it if you rewrite the equations again. So there you go. So now, these COs, 3 COs cancel 3 COs, 3 CO2s cancel 3 CO2s, and we're left with 2Fe plus 1.5O2s, and they give me Fe2O3. And then to find the answer, you just add those together. So basically negative 848.88 plus 26.7. Negative 800. 23? 22?
But I thought that the 2 on the bottom were supposed to add up to the 1 on the top.
The question is, what is the 1 on the top? They didn't give you the 1 on the top. So that's why you just made the 1 on the top. Right? So, and then you added them together to see what that equals. Do it. Try this one. Okay, so first thing I see here, I need carbon dioxide on the left. I have carbon dioxide on the left. I need some carbon on the right. I don't have any carbon on the right. So it looks like this one is definitely going to need to be flipped. So CH, some C. Okay, and then this has to be positive 74.8. Okay? So now, good, because now this CH4 will cancel that CH4. Now anything with H's in it is no good. So I got some water here and some water there. Some hydrogen here and some hydrogen there. So here's a couple problems I see. I have 2 water on the left, only 1 water up here. I have 2 hydrogen on the right, only 1 hydrogen up there. So in both cases, this one needs to be twice the size. So double it. And then double this. I just did that in my head real quick, so it could very possibly be incorrect. It's right? I'm a little impressed, I'm not going to lie. So
I'm a little impressed with myself.
So now you can always just check and see if it works, right? So 2 H's cancel each other out. The methanes cancel each other out. 2 waters cancel each other out. Oxygens. I have 2 oxygens over here and 1 oxygen over here. So the 1 cancels each other out, and then it's going to leave just 1 oxygen left. So we're going to have CO2. I don't see anything else on the left. Plus C. I don't see anything else. Plus RO2. And then if you add these 3 things together, what do you get? And is that positive or negative? Okay. So positive 393.7 kilojoules.